questions on setting these up? I know we did a couple of them yesterday, but for those of you that weren't here, any questions? You want to make sure that you get the major axis that has the vertices. If your major axis is your y, then that larger number, the a squared, goes under the y. If your major axis, is your x, then that a squared is going under the x. Okay, make sure you set it equal to 1. After you go through this whole thing, set it equal to 1. Unless you have any problems, I'll move on. We did some of these yesterday. I know we did the passes through, because that one was a little bit different. It's the same as when you did when you passed through a point on the parabola. The parabola made it a little nicer to work with, but this was still doable. Whether you found a common denominator, I found a common denominator, or yesterday I had us move this to the other side and cross multiply. Whichever way you do it, it works out the same. The vertex and the co-vertex, those are the nice ones. You got your A and B right there. You don't even need to bother with anything else. You find your midpoint. Everybody can find the midpoint, find the vertex. Average of the x's, average of the y's. Okay. If they give you an axis length, don't forget to cut it in half. Because your letter, A, B, or C, goes from the midpoint to the vertex, the center, to the end point. So don't forget to cut those lengths in half. Foci will give you the C. So find your center in the middle and work from there. Questions at all? Everybody's good with this? And this one was a little different. I think we did this one in class as well. We found your vertices, so we found A. Then we just had to plug A into the 2C part and find C. Then we had to find B. When you do this and you're looking for your equation, I wouldn't even go down to B. Just go down to B squared. Because you're putting the square in there anyway. Don't forget to square it. The numerator gets squared, the denominator gets squared. Good? Alright, today, and it looks just like your ellipse, except this is a minus sign instead of a plus. Now, notice also, this time, the A and B don't move. A has to come first. What's going to switch are these two parts. These are going to swap. In addition, it didn't matter. When we add it, it doesn't matter what order you add them in. But what you want to remember is, it matters what order you subtract in. I could do 3 plus 4, 4 plus 3, but I can't do 3 minus 4 and 4 minus 3. They gave me 2 different answers. So that's not a commutative property. So we're going to have our major axis come first. Just make yourself a little note. On a subtract, just remember to yourself, subtract, it matters which order you subtract. So your major axis is going to come first. So therefore, if my x squared is on top, that's my major axis. If my y squared is the first one, then y is my major axis. No, the ones I just handed out. Hang on. There. All right, so we're good with that. So basically, your vertices come the same way. H is always before K. Your co-vertices will be there too. It will be on the minor axis. Your foci this time will come in outside. Your hyperbola, by the way, looks like this. It looks like this. It looks like 2 little parabolas. Or it could go the other way. If it's an x squared, it's going to go, if it's a y squared, it's going to go one way, x squared, it's going to go the other way. Now, here's the problem. we need to have some way to make these be symmetrical. So what we do is we make a box in here. This is where your vertex is, right here. Your co-vertex technically doesn't exist because it's not on your hyperbola. But we call it a co-vertex because we need to make that box. Because what we're going to do is make a transversal that goes through here. These are your asymptotes. It's going to be an asymptote to guide how wide this hyperbola gets. If it's narrow, then we have a narrower hyperbola. So we're going to make a box out of your vertex and your co-vertex. And we're going to send these little lines through, which are these asymptote equations. Now that looks really scary, but when we do it, it's a lot easier. It's just the slope, and we'll fit it. That's your point slope format, in case you recognize that. That's which really is like your point slope. This you take from here. This is from here. This you take from here. And this is your slope. It's just your change in y over your change in x. And because it's squared in here, we're going to take the square root of it. So really, it's not that scary looking. You'll see when we do it, it's not that bad. Also, do you notice the formula? This time it's a squared plus b squared. What the plus does is it pushes your focus outside of that little area. An ellipse would have looked like this in here. And your focus would have been inside. Your hyperbola, your focus is outside. So we're adding them. What happens when you make a mistake and you subtract them? You end up inside that box. Your focus is not inside your little parabolas there. So you'll notice right away when something is off. Again, we complete the square to get there, and you'll see that there's a minus. And you'll recognize your hyperbola by x squared and y squared, and the minus in between it instead of the plus. That's why I like to do these two together, because it's almost the same format. So let's take a look at one. Keep your note page next to you. It's easier if you have it around you so that we can walk through this. Okay, and we'll do two of them. Maybe if we have a chance, we'll do one of your homeworks. And you can do the homeworks in class tomorrow. So we're going to start real basic. What would the center? What would the center of this hyperbola be? 0, 0. But we have no h, we have no k. So 0, 0. Whatever comes first is your major axis. It's called, your major axis is called a transversal axis. Because this is where your hyperbola transverse off of. So if x is your major axis, your hyperbola is going to transverse off of your x-axis like this. Well, it's going to look like this in a minute. So again, this is your a squared. A squared and b squared don't change. So again, you have a, b, and c. Square on the top and square on the bottom. So a would be 4, b would be 3, and we're going to use your formula with the plus in it to find c, because our focus needs to be outside of it. If we subtract it, it would put it inside. If we add them, it'll bring it to the outside. So we're going to say a squared plus b squared. You have your a squared and b squared. God bless you. So c is going to be 5. See how it's longer than your major axis? Your focus has to be outside of your hyperbola. It's like it's two little parabolas. See them? There'll be two little parabolas for both. Okay, so now we start. Here's your center. It's the center of what makes your hyperbolas symmetric to each other. Now, on the x, you do the same exact setup. Left the x, plus or minus 4. This is a vertex. This is a vertex. So we have a vertex at negative 4, 0, and at 4, 0. Technically, we do a co-vertex, but the co-vertex really doesn't exist on your hyperbola. So we have to make the box. So 3 up, 3 down. And we really don't call it a co-vertex, but it works the same way. Now, normally if you were making an ellipse, wouldn't we just make this little oblong circle here, right? Instead, it's a hyperbola. We're going to make a box. We're going to make a box. And we're going to put 2 diagonals through this thing. We're going to make a diagonal this way and a diagonal this way. These are called asymptotes. This is an asymptote. Okay? Watch how easy it is to get the equation of this asymptote. You're going to go, whoa, so we went up, how many to get here? 3, and over 4. And the other guy is going the opposite way. The left way. We'll use the formula in a minute, and I'll show you then you can do them both at the same time. But not to make it scary, they're just 2 lines with opposite slopes. This one's going up 3, over 4. So if you forget your formula, you can always just figure it out using a point and a slope and a format for this. Right now that passed through the 0, 0, so we're okay with that. Okay, what that helps us do now is draw your hyperbola. You use that asymptote as a guideline. It can't touch the asymptote, it can't touch the box. It starts at the vertex, it's like 2 little parabolas. It starts at the vertex, and we use the asymptote as a guideline. They'll tell us like how wide it is. There's no x and y intercepts on these, so you should be happy about that. We use the box, and we use the asymptotes as our guideline. Now your focus will sit inside here. So that's why it's a little extended. So your C is 5. So your focus is 5, 0 and negative 5, 0. See where your focus is? Outside. Your focus on the ellipse was inside the ellipse. So we subtracted those 2. On the hyperbola, it needs to be outside. So we add them together. Push us out of the box. Basically, this is your hyperbola. Now, if you take your formula, this is your y minus k part. This is how you can build your asymptote without even taking it off your graph. This part comes from here. This is your y minus k part. There is no k in here, so it's just plain y. No square, because we're making a line. So if it was y minus 1 squared, we would put in here y minus 1. And then we would solve the rest of the equation in minutes. But it's just y, plus or minus. This guy over here is just x right now. There was a 0 for your vertex. Your square root of your y denominator. Come to your y denominator. This is what your slope is. Your slope is your change in y over change in x. So the square root of your y denominator is 3 over the square root of your x denominator, which is 4. And then this guy has no h, so it would just be x. So it's exactly what we got if we had to go off of your graph and we didn't know this formula. It is exactly the same. It just builds the boat. What's helpful is when it doesn't cross at the 0, 0. Because then you're going to take your y minus 1, your x minus 2, which everyone knows have to be, put the slope in there, and we build your line. So that's really not too bad to do this. It's really just like your y. It's almost like y equals mx plus b, but we don't have that little plus thing there. And that's all there is to your hyperbola. It's not bad. It's a little bit easier to graph. I can draw these better than an ellipse. My ellipse is very bad. But these aren't so bad. So let me see what else I can. Okay, so we're ready to try another one? Of course, you know that gets a little bit tougher. Okay. Before we can do this, we have to do what? Complete the square. No different than when you did the ellipse. Get your x's together. Just order this. Some of you, guys, I noticed are having a hard time when we move the pieces to the other side. When you were doing the parabola, you were forgetting to take the opposite. Like if you had two adds, you were forgetting to subtract both to get them to the other side. So be careful when you move these around. On the same side, it stays. We don't do anything. We don't have another y. This guy has to go here. Take the opposite. Now, only the one we have to worry about is this x. Make a little space next to it. So we have to have a coefficient of 1. So what do I have to factor out of this little group? 4. Leave the x's there because that's the one you want. You want to complete the square. So leave the x there. So what's half of 2? What's 1 squared? 1. Now it's trapped in that parentheses. You have to distribute this out, just like we did with the ellipse. What's 4 times 1? Okay? So now we move the 4 to that side. We leave this guy alone. We bring this 4 down here. We leave this guy. He's going to have a 0 here because there's nothing to complete the square. Combine the terms just like we did before. This will give us a negative 12. Now, we have to divide to get that equal to 1. The ellipse, we didn't have this problem really. Everybody had to be positive. But the hyperbola has a negative in between, has a minus in between. So what are you going to divide by to get that equal to 1? Negative 12. Now, notice the first term is going to become the negative. The second term is going to become the positive. So I'm going to put my second term first. This is going to go in here 4 times. It's going to be y squared over 4. That's going to be my positive term. My negative term is now in the middle. And 4 goes into 12 3 times. So here's the equation of your hyperbola. Which one is the major axis? Y. The y comes first. God bless you. When the y comes first, it's the major axis. Okay. Now, what's my center? Take it out. Negative 1, 0. Good. My y-axis is my transversal axis. That means my hyperbola is going to go this way. It's going to transverse off the y-axis. Okay? This guy is now my A. A and B don't change. So what's A? 2. What's B? Radical 3. And now I've got to do c squared equals a squared plus b squared. So there's my squares. 4 plus 3. C is radical 7. It's okay to have fractions. It's okay to have radicals. Just keep your radicals in reduced form. Okay. Ready? Let's sketch what we have. Sketching is good because I don't mind sketching these. Find your center. Negative 1, 0. If it helps, make your transversal axis just like we did with the ellipse. Find your center. Now, your major axis is your y. Y is going up 2, down 2. These are your vertices. This is where your hyperbola is going to come off of like this, up and down. Technically, we don't have a co-vertex, but it helps us make the little box. So we go over radical 3. Radical 3 is about 1.732. So you come over here a little bit more than, this is 1, so a little bit more. and over here. That just helps us make the box for this. So we make a box. And now we make your asymptotes through here. Start at your center and make your diagonals. We've got your vertices. Your vertices were at, if this is negative 1, 0, this one up 2, so this is negative 1, 2, this one down 2, negative 1, negative 1, negative 2. We don't need your co-vertices here. We just needed them to help us make that, the asymptotes. Now make your hyperbola. Your hyperbola is going through here. Use your asymptotes as a guideline. There's no intercepts for this because normally with the parabola we don't know how wide it is, so we look for intercepts. But because we use your asymptotes as a guideline, we don't have to find any intercepts. The only thing left is your foci. They're inside your hyperbola. And they're C units away. So since it's a radical 7, we can just say your foci is negative 1 plus or minus radical 7. This guy is negative 1 comma radical 7. This guy is negative 1 negative radical 7. Good so far? Yes. The y denominator, we're going to build your lines in a minute. And A and B always are first set. The y is with whoever comes first is the major axis. Now, we're going to build your denominator, your line. This one's a little different because it has an intercept. So this one, you're definitely going to have to use your formula. So here's your formula, but it's not so bad. This is your slope. Okay, there's your formula for your asymptotes. We can count your slope. We can figure it out if we use y equals mx plus b and plugged it in and found your intercept. But we're going to fit it right into this formula. Here's the y. The y has nothing here. So the y is going to stay. Don't put a square because it's a line. Plus or minus. Find your y. Take the square root of this guy. 2. Find your x. Take the square root of this guy. Radical 3. And just put this in here. X plus 1. There's the equation of your lines, of your asymptotes. And the only one we would have to worry about, we can leave this just as it is, and we can leave a radical in your denominator, because we don't have to rationalize. The only time we would have to worry is if, for instance, it said y minus 2, and you found this. You just have to add the 2 to this. Just bring the 2 over here and put the 2 right in front. 2 plus or minus, and you could leave this, the rest of it, the same. You don't have to distribute anything. You don't have to collect the terms. You just have to make sure it's a y equals, because it's a line. So the only time we would have to worry about it is if we had a term next to the y. Good? Questions on your hyperbola? It's really not that bad. Not a lot of extra to it. The only thing, you're still doing your A, B, and C. You're still doing your foci points, that's inside. So the formula just is a squared plus b squared inside. You have asymptotes. You have the equation of your asymptotes. It's really not so bad because it's the change in y over the change in x. God bless.